Hello and welcome back to the next episode in the series on the EV conversion of my Fiat. As you can see, I've got the Fiat in the shed and up on a hoist, and I've now managed to get a few of the bits and pieces together. So in this episode I'm going to talk through some of the bits and pieces and the electrical system that I've managed to gather so far. So let's go. Motor and controller from a guy who had done an EV conversion on a combi van, and this was a little underpowered for the combi van, and so he's upgrading and he sold all of this to me. And on Facebook Marketplace I found a guy selling battery modules from a wrecked Kia 6 EV, and I bought a bunch of them. I'm going to run this system on about nominally 110 volts, so that's five modules like that, and I've actually got another 5, so I'm going to double them up. But before I actually do any installation in the car, I'm going to set it all up on the bench and just make sure that it's all working. So I've now managed to get my setup working on the bench. I have here is a 15 kilowatt Schnegel, I'm not sure how you say that, motor from China, connected to a Kelly controller, and I have batteries from a Kia EV6, the Ziva BMS, and a TC charger. So I'll talk you through all of that and show you how I've put it all together. Alright, it is a little bit of a rat's nest, but I will try and talk you through the whole circuitry if I can. So, as I said, we have the battery pack here. The negative of the battery goes through here to the negative of the controller. We have the positive of the battery here, which goes through an isolation switch. There will ultimately be a fuse and an emergency switch. And there's the current monitor there, which goes through to the main contactor, and then on to the positive of the controller. It's a 3-phase induction motor, so there are 3 phases going to the 15 kilowatt motor. So that's the traction circuit. Actually, before I do this, the charging circuit, I'll just explain the pre-charger. So when the contactor is activated, if this is not charged, this has some large capacitors in it, and if the contactor closes and these capacitors are discharged, then it's essentially like closing the contacts on the battery, and there's a massive rush of current, and that can weld the contacts of the contactor shut. So you need what's called a pre-charge circuit that allows the capacitors to charge slowly before the contactor opens. And so that's there is a pre-charge in this EV-MS3, but I have not been able to get it working, so I've made my own. So I have a large resistor here, and essentially the pre-charge circuit, what it does is before the main contactor is activated, it switches this resistor in, which is just across those 2 terminals there. And I do that with a little timer here. This is a little timer circuit that came from eBay or somewhere. And what you'll see is when I turn the key on to the auxiliary setting, this comes on, and after a few seconds clicks. And what that did, it connected this resistor across there for about 3 or 4 seconds, and then it switched it off, and that should be enough time for these capacitors to charge up. And what that means now is when I turn this on, you hear that click. That was the main contactor activating, and that won't have welded itself shut, I have actually welded a couple of contactors shut before I got the pre-charge circuit working, so it is important to do that. Yeah, so that's pre-charge. So this is the charger. So this has 3 essential inputs into it. There's a 240 volts input, which is how the car will charge, where it will get its energy from. It has an input from the main traction pack, and that's this one here, which comes out, and you can see those 2 wires there and there connecting to negative and positive of the battery traction pack. And then it has a CAN bus connection, which is on the same CAN bus circuit as this entire communication system here, and this particular charger, this TC charger, can actually be controlled by the EVMS3 through CAN bus. But there are ways of controlling chargers that don't have the CAN bus functionality or have a different protocol or whatever. But this one does, so that's good, makes it easy for me. So this is also got a DC to DC converter. It takes the voltage from the main traction pack, which is somewhere around 110 to 120 volts, as I said, and converts it to a suitable voltage for charging the 12-volt battery. So that keeps this 12-volt battery topped up at all times as well. Essentially, it's like the alternator in an ICE car. I'll turn this on so you can see how it all works. So I've got a switch here which is just turning on the 12-volt battery. That just isolates that. So this is in the state the car will be in when it's just sitting there with the ignition off. You can turn this display off so it doesn't have to be on all the time. I think you do that by just holding this for a while. Then you can just turn the display off so that it doesn't have to sit there with the display on. But then you can just turn that back on by holding that. So yeah, basically you can see there's a bunch of screens here on this, the Ziva BMS system. So you can actually see all of the individual cell voltages. At the moment, this is module 0, which is the first 2. Then you can go and look at the next pair, and then finally the last one over there. And you can see they're all sitting at around that 3.68, 3.69 volts. It's also monitoring the temperature of each cell as well. Well, except it's not, but it will be when it's in the car. You can see it displays the average voltages and the temperature, and then you can, and then this is what it shows when the car is ready to drive. I'll show you in a minute what happens when you turn it on. But in this state, we can also charge the cell. So to charge the cell, we need to turn this, which will be some kind of a safety switch that will only be activated when the car is plugged in. So it might be the flap to the charging port or whatever. So when that's switched on, you can see it says the EVMS is charging, and I'll just turn the bank on and turn the charger on, and then we'll see that it's charging, and the current total pack voltage is 110. If we go to the charger status, we can see that the target volt is 120, so it will charge these cells until the total pack reaches that 120 volts. It's putting in about 10 amps, 9.9 amps, and there are a bunch of parameters that you can set in here to ensure that no individual cell goes above or below a certain voltage. So that's the system. When it's in the car and I want to drive, essentially the process will be turn this on. As I say, the pre-charge circuit will come on, pre-charge, then I can switch this on. It's now ready to go. I have my accelerator pedal here and the forward and reverse here, so if I put that into forward and press this, the car drives. Similarly, I can go backwards. there's a whole bunch of parameters that can be controlled in this Kelly controller via a laptop, and there's a laptop interface here that allows you to do that. I'll maybe go through them in a separate video. But essentially, that is the system. There's a few more safety features to build into the system, fuses and emergency cut-offs and inertia switches and so forth. But essentially, this is the guts of the EV conversion. There are a couple of other wires which in here which I haven't explained, but what I'll do is I'm going to prepare a circuit diagram which will explain all of this, or illustrate all of this in a slightly neater form. Okay, well, a couple of updates. I have managed to resolve the issue of the pre-charge circuit, so I don't need that external pre-charge circuit anymore, and I can show you exactly how it works now. Again, everything's on. I turn it on and you will see the pre-charge is now worked. You saw that quick charging and then the click on the contactor. So the pre-charge inside the EVMS3 is working, and the reason it wasn't working was that the charge contained in the capacitors in the controller wasn't discharging fast enough when I turned it off, and so it needed a discharge resistor put across the terminals. I think this is a 10k resistor, and that seems to have solved the problem. So now I can turn the car off, and as long as I don't turn it on again within about 3 seconds, the pre-charge works. So essentially we have a system that's now ready to go. I will now dismantle all of this and start to pull the engine and other bits and pieces out of the Fiat. So the next big milestone. Stay tuned.